Thanks a lot for the invitation, Max and Simon. I think the previous presentation was perfect for discussing also the topic of supply. Where should the practically material streams that will allow for the production of recycled critical metals come from? And this is practically the problem that we're tackling in NIU NIU. So I think we are all aware of the environmental destruction related to the disposal and very often the not so great disposal of electronic waste. And we all know that these material streams contain also critical minerals such as cobalt, lithium in the batteries, but also gold, platinum, and copper in the printed circuit boards. And it's estimated that every year we waste 60 billions of these critical metals in these material streams. And important to mention, without taking into consideration the disposal from the industry. So this is practically just post-consumption. And the demand of these critical metals is expected to grow to 166 billions by 2030, only from the climate tech industry. So this without taking into consideration telecommunications and defense, which are large consumers of these critical metals as well. And what we have identified over the past 5 years is that the bottleneck is not just the lack of infrastructure, but also the lack of structured data that allows for the capitalization of these material streams. And this is a problem that we are tackling at NIU NIU specifically. What we are building is an intelligence layer for the circular economy of secondary critical metals. And this might sound a bit abstract, so I will go deeper into that in a second. We received a grant from the United Nations back in 2021. And since then, we have secured contracts with the largest recycling refineries in the US for printed circuit boards in Europe and also in Asia. So how does it work? What we identified is that we are in a double-sided demand-driven market, which has large OEMs and large e-waste producers on one side and technology companies on the other. We connect those large e-waste producers with dismantling plants and aggregators through something that we call an ESG scheme, which tackles their scope 1 and scope 3 problems. We then enable these plants with our AI sorting technology, which we developed with our own data sets and created our own models so that they can classify the material based on the critical metal content and value. And we then connect those material streams with the refineries that can really extract lithium, cobalt, platinum, etc., out of these very heterogeneous components. And one important part to mention there is that the Basel Convention regulates the transboundary movement of e-waste, which makes it harder practically to export batteries and printed circuit boards from the south to the global north. And this is a highly regulated, and this is a problem that we're tackling as well at NIU NIU. Our business model is based on those regulations. And last but not least, with the information that we have along the value chain, we can provide full transparency of where these metals are coming from. And we are currently assessing this new standard for traceability and looking how we can implement it into our platform as well. So the benefits are 100% traceability, shorter payment cycles between the dismantling plants and the refineries by the early identification of value, and higher productivity at the human-machine interaction with the use of our technology. Our computer vision algorithm allows for the early identification of the metal content and value in the most heterogeneous components, such as the printed circuit boards, and for it to be sorted. The market opportunity in Mexico is considerably high, given that the largest electric vehicle producers are based here and they have huge amounts of batteries in their ramp-up operations. So we help them to dispose of their materials with a seamless process. Our team is out of international engineers, data analysts, lawyers, and economists, and we're backed by venture capital firms that secure our growth. Our business model combines AI-based classification, outsourced logistics, specialized logistics for this kind of material streams, and then a managed marketplace. And soon we want to integrate also financial products into our platform to make the flow even larger. Would be from my side. Happy to hear your questions.
You are still muted, Simon.
Sorry, my apologies. Dylan, thank you for the insights. I would have a short question directly. Does the recycler need any special equipment? Are you advising them on camera, etc.? Because as I understood, you're using a visual algorithm, like visual detection, to put data to the matter, so to speak. What are the requirements there for companies to use your digital know-how?
Not just having a mobile phone. So we are practically, our aim is to decentralize the identification of value in these components. So this should be usable in any mobile phone that can be Android or iOS. Yes. And sorry. So that's something that I forgot to mention is that we're looking for collaboration with companies that can reduce the risk in the transportation process. So practically how we handle the batteries in the early stages after we identify their value, so that the risk of transportation to the refineries can be lowered. So if there's anyone in the room that is interested into this topic, please feel free to contact me.
Okay, gotcha. So it's, then I think my question is answered. Does anyone else has a question on this inspiring tech that is kind of, closing the loop, I would say. I think that is really what the key value here is. If not,